Hello and welcome, everyone. My name is Dr. Todd Fiore. I'm the program chair for the PhD in Organizational Development and Leadership program here at University of Arizona Global Campus, and I will be hosting this session. By joining us today, you acknowledge this session is being recorded and will be shared with TLC-related materials. Microphones will be muted for this presentation, but we encourage you to pose questions and comments in the chat. We have also enabled live transcription. If you'd like to use it, click the Show Captions button at the bottom of your Zoom window. Now, I am pleased to introduce you to our presenter. He is an experienced aviator, researcher, and organizational development scholar whose work explores the intersection of artificial intelligence, human factors, and trust in automation. A former Marine Corps MV-22 pilot and operational test director, he has led teams in complex, high-stakes environments and now serves as a corporate pilot on international missions. His doctoral research examined pilot perceptions of AI-enabled systems using the unified theory of acceptance and use of technology frameworks. Passionate about integrating human-centered design into emerging technologies, he brings a unique blend of operational expertise, academic rigor, and practical insight to the discussion of how humans and machines can effectively collaborate. Welcome, Dr. Christopher Healy.
Hello, thank you. Appreciate the introduction. So what I did was I did a study, mainly this is an extension of my doctoral dissertation where I interviewed pilots to understand what factors they felt would be pertinent for implementing AI in cockpit automation. One of the initiatives, at least from an AI and aviation standpoint, is leveraging AI to potentially reduce pilot workload and make aviation safer. Some room, but here, next slide. So general overview. At this point, most of us are very familiar with AI. It's a fairly disruptive technology in terms of how organizations intend to use it. However, one of the challenges that, from an organizational standpoint, is organizations are spending a lot of money and resources trying to integrate these AI initiatives. However, about 85% to 80% of these AI initiatives kind of fail or go underutilized. Where I focused was aviation as a high reliability organization. Typically, any organization that consistently makes high risk type decisions while also maintaining a high safety record. As you can see on the right side of the screen, though, AI has not been without fault. You can see instances of AI giving incorrect information. Amazon, their products ended up drifting into a gender bias, and then even in the healthcare industry, how it kind of overpromised and underdelivered. So some of the technological challenges specific to aviation is, as we've introduced automation into aviation, we've also found new ways to mess things up. The International Air Transportation Association, IATA, identified that automation errors account for over 80% of aircraft mishaps, whether that be data entry errors, turning dials too far, misreading information, and even though it has increased overall safety, we basically found new ways to screw things up, and that blends outside of aviation. I think we'd see that in many institutions where we've tried to use technology to overcome human error. So some of the issues as of 2025 that we really see with AI, as large language models start becoming the norm, we're seeing hallucinations, essentially meaning AI just kind of makes stuff up and starts drifting on what it thinks is correct or incorrect. That leads to lack of trust or over-trust. And one of the things that we're actually starting to see now is a term I recently heard called AI slop, where people are just using AI to generate articles and write things, or integrate into workflows, but not really policing what it's doing and causing more issues than it's worth at that point. But where I find some of the integration challenges is the way we're interacting with AI. From the picture on the screen here, you have the person who's sending either a request or information through an AI system, think ChatGPT or Grok. Um, yeah, definitely treating the hallucination as a viable information is definitely an issue I've seen, Jackie. Um, but what we've what's going on behind the scenes is now there's a data set that I was using. There's a machine learning process going on continuously. And then you need to ask yourself, well, how is it trained? Why is it making such a prediction or a response? And now it's providing that information to the user. And then even with that, there's challenges with, let's say, the completeness of the explanation, the time constraints that the person may have to verify that information. And their own level of expertise in the area as well. For instance, I use AI to assist with coding projects. I know just enough code to correct the mistakes that AI makes. However, someone with no experience may have a little bit more difficulty trying to figure out what AI did right and wrong. The purpose of my study was a basic interpretive qualitative study designed to understand pilots' perspectives, essentially just asking pilots what you think based on a couple of research questions and gathering their response. I wanted to take their subjective experiences and viewpoints and kind of identify potential strategies for integrating AI into aviation operations. And when I say aviation operations, that could still be relatable to various organizations, specifically even in education. So my research questions that drove the study was, what are the perceptions of pilots regarding their trust in AI technology? What are the perceived challenges in trusting AI in cockpit operations? And what factors do they identify as important for integrating it into cockpit operations? Boiling it down to, hey, what do you think about it? What do you think the challenges are? And what do you think you would need to effectively put this into the organization? Now, like I said, although I said pilots and cockpits could be swapped out for educators and classrooms. What I found as the importance of the study is there is basically a knowledge gap between what end users know about these systems and how to use them optimally. And specifically in aviation, there's a paradoxical relationship with cockpit automation where although we try to put things into the cockpit to make aviation safer, humans being humans, we find new ways to make mistakes, and there's always unforeseen and unintended consequences of actions that even the engineers may not have thought of. So when we relate this into education, we ask, well, does the automation paradox exist outside the cockpit? Say possibly. Some of you may have used a whiteboard and then gone to the smart boards, their progression. I remember in my experience in the military, the Marines kept writing on the smart board with dry erase marker, turning it into what I call the dumb board. Every smart board we tried to implement into our squadrons was a catastrophic failure because no one knew how to use them and never really achieved its full benefit. But we're also seeing research, not all bad, but focusing on what some of the people fear for issues for AI is it eroding the ability to study and problem solve? And then also the relationship between writing something physically by hand and you having your brain memorize what you're writing versus just looking at information. So what I did was came up with a framework, came up with an interview, found pilots, kept interviewing until I got data saturation, conducted a thematic analysis, and reported the results. For my first research question on the left, you can see the questions that I asked that were tied to the first research question, and a couple of key quotes on the right. People generally had varying levels of understanding with AI. Some felt it could be good, potentially alerting us to things that we may have missed during high workload periods. I would agree with that. And then others identified that machines can fail, it can misinterpret data. If you ever had to try to have ChatGPT generate a picture for you, you know it's kind of close, but doesn't always get it right. And one of the themes across the responses was they still wanted to be a decision maker or had the final authority in the overall process. So really what that boiled down to was there are varying levels of understanding between what AI can and can't do, and that aligns with other research that we've seen. And then I was very cautious. One of the things that came out of the research was that trust scaled with risk. Essentially, the closer you were to the ground or where the outcome was potentially fatal, there was less, rightfully so, trust in the system. However, if it was a fairly benign outcome, I felt trust would be higher. But in all situations, the end users, in this case, the pilots, absolutely want a human-in-the-loop type model to support rather than replace the judgment of the pilots. For the second research question, the perceived challenges, many of the pilots felt that they wanted to be able to override it. They wanted to be in charge and essentially still had the final authority. They want the word reliability or reliable, vetted, those came up quite a bit. And one of the things I found interesting was they did talk about generational issues, implementing AI, but there really wasn't a definitive cutoff to say someone in Gen X, Y, Z may be better than the older generations. Someone in around the age of early 60s was saying he was worried about the older pilots, and not to say 60s is old, but someone who's 62 is essentially at the end of their aviation career with a retirement age of 65. So I was like, I don't think there's many older than you, but still a valid point. So the three key points or takeaways from the second research question was maintaining human control has to be reliable, and there may be some generational differences when implementing it. One of the other things that were brought out with the reliability and testing is standardization, and we see this now if you're using ChatGPT versus Grok or Bard. They all work slightly different, and there was a concern to say, well, everyone's making their own AI. How do we know which one's going to work or how it's going to work? And we could see that in the results of research question 3, what they identified as important. They said training specifically for them, knowing how they use it, they found to be fairly important. Thoroughly vetted, standardization, as well as education being very as a key enabler of implementing this technology and using it effectively. So the three highlights from that came down to training and organizational support. In aviation, we leverage simulator-based and scenario-based training quite a bit, where a lot of people identified a use for learning would be different edge case scenarios where AI would augment human decision making. For us as pilots, we had the Federal Aviation Administration, which is kind of our regulatory oversight, looking for basically key agencies to give some kind of stamp of approval, and knowing that there was some level of standardization among the systems. One of the pilots did bring up that, well, if I fly a Boeing aircraft, would the AI work differently than something proprietary in an Airbus or a Gulfstream model aircraft? And lastly, they did discuss peer endorsements and transparent communications. Really, if they found that people that they were respected within the industry endorsed the use of the system, they felt that would make them a little bit more comfortable in embracing the technology. Aviation is a very seniority-based type organization where the people that have been around the longest have the greatest say in how the industry is going to be shaped, and the more junior pilots within the let's say like Delta felt that, well, if my chief pilot says it's good, that's good enough for me to you know, try to implement it and utilize the technology. So when you combine all three of these research questions together, what you see is trust being a dynamic and multifaceted construct. Really, the understanding aspect of it, the interplay between reliability and human oversight, and these are very nuanced areas for understanding how to implement and use AI effectively. They talk about user-friendly system designs and human in the loop being the key decision or a key factor. And where that came from was pilots saying, well, as these are being developed, they shouldn't be developed in a in a in a sealed environment where they wanted to have some kind of say and input going down the future for how they would be used. As a human factors professional, that's kind of within my wheelhouse, where I was like, well, at some point, you do need the human element to kind of bridge the gap between the engineer and the end user. And really, it came down to conditional trust, being that they'll trust it, but as long as they can understand what it's doing and have some kind of oversight into it. And a lot of it, from what they said, kind of stems from the more they felt they would use it, the more trusting they would be. I felt it was analogous to if I fly with a very junior co-pilot, I may kind of trust them, but early on in the flight, I'm gonna probably pay a lot more attention to what they're doing until they've proven to me through their actions that they are capable at handling varying levels of tasks of the different degrees of difficulty. There are practical implications of this. When taking an implementation approach, it just requires a holistic approach. There has to be some kind of regulatory framework, accessible explanations of how it arrives at its decision was a big point within the responses. And that also marries a lot of other research that says, well, people need to know or follow up and ask why. And one of the examples I had from my experience was I was flying to a small airport in London, and I had no idea where customs was, but I had time to kill. And I asked one of the AI models, hey, I'm flying to such and such airport. Where is the customs facility located? And it gave me very detailed instructions to say, well, make a right off the runway, taxi down here to the south, and it's located at the south side of the airfield. I knew that was completely preposterous. And all I followed up with is, are you sure? And it said, well, you're right to question me. It's actually located on the north side of the airfield, and gave me entirely different instructions. At no point could it tell me or rationalize how it got to that decision point. And that's the difference between right now where AI is in terms of the ability for it to explain itself versus if I have another human, I mean, my co-pilot, and if you're to say, oh, I think customs is located here, and I would follow up with, how do you know? And he or she would provide me with some kind of, at least how I got to that decision or conclusion. But it needs to be, like I said, context-specific training. Regulatory oversight came out as a pretty big factor. And then with any large system, I would say encourage industry-wide collaboration and peer mentoring. How this parallels teaching and learning, aviation was designed to enhance safety, yet there's new errors and that we make with it. Same thing in education. On the right side of the screen here, here's a tutoring assistant for one of the tutoring companies I contract with, and although it's a good system, there's a lot of things that it doesn't do well in terms of making specialized, tailored instructional aids and tests and lesson plans, even though that's kind of what it was designed to do. And the first time I had it make a test for me, it had duplicates in there, and I put a little too much trust in it. So really, kind of ties into my second bullet point, where even though the technology is great, it still needs to be done from the standpoint that it shouldn't replace human expertise. It should just augment and kind of assist, making lives a little bit easier, not harder. So just as pilots must stay in the loop, educators must also remain engaged in critical decisions and not just give free range to the AI tools that are out there right now. So for my final thoughts on the topic, really what I see here is a communication model that's that we are now just communicating differently as we would with a human. Jackie made a comment that AI must be educated / trained does not equal intelligent. And I would agree with that. You know, I always, when people are like, oh, I think you must be smart. I'm like, well, no, I wouldn't say I'm smart. I'm educated. There's definitely a difference between the two. And I work with some companies involved in the training of the of those models. And again, it knows what it knows, and it makes up what it doesn't know, and that could create an issue, especially if you don't understand the capabilities and limitations. But so on this model, you have the receiver being the human, a message that goes through some noise, AI that must use a data set, machine learning process, and with its own capabilities to provide an answer back that goes back through a filter, and it creates some overall challenges. So a core message is trust in AI shouldn't be automatic. It should be balanced through integration of technology and oversight. I always felt that AI could be analogous to a very competent intern that is unwilling to say no or not give you an answer. Meaning that if you ask it a question, it will give you an answer, but may not necessarily be the right one. And utilizing it as a tool and understanding, or the end user understanding that it is just a tool and requires a different skill set, will help improve the implementation and the effectiveness of it. Does require a certain level of transparency, even from a requirement standpoint, and then validation, and then ongoing training. One of the things, if you're a user of ChatGPT, it's on, I believe, version 5 plus now, but there's been several versions along the way. Each one is slightly more capable in some areas, but then maybe less capable. It does something different in other areas. And it's not a static learning module for the end user. As AI evolves, so much the training and so much the recurrency of the training. And like I said, my final thought, it's very requires a collaborative approach to implement it effectively and utilize it effectively, where what we're trying to do is blend human judgment and technology, and leveraging the trust factor to use it correctly. So at that point,
sorry, Dr. Healy. We do have a couple of questions here in the chat. If we could have you address them. Patrick asks, if a pilot is certified to fly with AI support, would they lose their certification to fly without AI?
So right now, the push is necessarily the regulation is wrapped up in terms of what's considered single pilot operations or extended single pilot operations to, for instance, right now, the aircraft that I primarily fly as a Gulfstream G450, it requires 2 pilots to fly. And then if I fly over 10 hours, I need 3 pilots to augment the crew. To assist with the pilot shortage, one of the great ideas was to maybe use AI to say, well, we don't need two pilots, just like we don't need navigators or flight engineers anymore. And uh, the AI can help the pilot. We're not quite there yet. The short answer to say is no. If a pilot's certified to fly, they're certified to fly, and that's it, with or without AI. It would just be the type of operation. So how the regulatory body would potentially shape up is hypothetically saying that I can fly my Gulfstream for certain operations as single piloted with AI, but for other kinds of operations, it may require two pilots or three pilots, depending on the time. And the second question that you have there, Patrick, do you see overlaps with the 737 MCAS? I did actually include that in my dissertation or discussions on that, mainly because there was a great article that said, well, AI could have potentially been a safety backstop as a control oversight to say, well, there's a fault within the system. Don't activate the stick pusher. The devil's advocate side of that is, well, what happens if the AI thinks there's a fault, but there is no fault, and activates the stick pusher? One of the challenges that is still to be identified how to solve is now you have essentially three different brains in the cockpit between the human brain, the aircraft's brain, and the AI's brain. And now when there's a fault, it becomes increasingly harder for the pilot to sift through what the correct action is or which one is now providing false information. I've flown plenty of aircraft in degraded states, and it was very easy for me to say, well, this sensor is clearly broken, so I know the follow-on progression of the issue, versus now if the aircraft saying something's broken, but now if AI is disagreeing with the aircraft, now I have to be the arbiter between two different systems versus one. So it could be somewhat challenging. Maybe interested.
Thank you, Patrick. Some very technical questions, which I'm sure you were happy to talk to. Looks like you two can connect. Chris, I guess the final question for me would be, or we have a question from Nicole. What would you say is the biggest setback or challenge you've experienced using AI while flying?
So AI isn't 100% integrated into the cockpit yet. However, where the long-term plan for AI is to be another set of eyes either inside the cockpit or monitoring the overall status of the system. Right now, I've had success before I get to the challenges where I've had a weird fault code in like a radio, and our maintainers couldn't figure it out. Put it into like a ChatGPT type AI module, told me exactly what the issue is. One time flying across, I was out somewhere in the Atlantic Ocean and trying to sift through some regulatory changes, and AI just kept giving me a different answer every time. I wasn't reliant on it, but it made it actually harder for me to think through what the right answer is, because I had documentation, confusing legal speak documentation telling me one answer and AI's interpretation telling me another answer. And I was like, I wish I never looked this up in ChatGPT, because now I don't know what to think. And nothing bad was going to happen, and nothing bad happened, but it was kind of uncomfortable because we were out of radio communication. And I was like, well, at some point, they're going to yell at me or they're not when I get back closer to the US. So we'll see what happens. And thankfully, it was uneventful. But I'd say that was right now the biggest setback I had, but a lot of misinformation. Do I have any other questions?
Dr. Healy, we are at time, and we do want to thank you because it's a fascinating subject. We want to thank you, the audience, as well, for your participation today. Please use the survey linked in the chat to nominate TLC presentations for conference awards and share your feedback on this presentation. Thank you again, Dr. Healy.
Thank you. You guys have a great day. Thank you for Running.